everyone. Let's solve LeetCode hard problem. Count binary palindromic numbers. The problem states that we are given a non-negative integer n. That means n is greater than or equals to 0. Now we call this non-negative integer as binary palindromic if the binary representation of that number means written without leading zeros. So suppose if we have the number 2, then its binary representation without leading zeros will be 1 0. Okay, so we'll be avoiding these leading zeros for in the binary representation. So if this that without leading zeros means 2 will be represented as 1 0. So if this binary representation is a palindrome, that means it reads the same from forward as well as backward, then that will be means binary palindromic. So what we need to do is we need to find the number of integers k which lie from 0 till n, and the binary representation of these case are palindrome. And what can be the case? Suppose we have 5. So the binary representation is 101. So we see like this value is equals to this, and this is, so this string is a palindrome. Hence 5 will be a binary palindromic number. So if we are given a n, then for each value from 0 till n, we need to return the number of values which are binary palindromic. And we are also given for the number 0, it can be considered binary palindromic, and its representation is simply 0. Means we can we'll be considering this, means avoiding leading zeros does not prevent this 0 for the binary representation of 0. So let's see the given input first. So we are given n equals to 9. So if we are given n equals to 9, so the problem means from 0, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's write the binary representation. So 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0, and then 1, 0, 0, 1. Okay, so we see this is a palindrome, this is also a palindrome, this is not a palindrome, this is a palindrome, this is not a palindrome, 5 is also a palindrome, 6 is not a palindrome, 7 is a palindrome, 8 is not a palindrome, and 9 is also a palindrome. Since we see 1, 2, 3, 4, we have 6 values from 0 till n which are binary palindromic. Hence the output for n equals to 9 will be 6. So what will be the most naive way of solving it? So we'll simply do what the question is asking us to do. We'll iterate for k from 0 till n, and for each k we'll see whether we'll construct the binary representation, and once we have this binary representation we'll see palindrome or not. Okay, whether this binary representation that we have constructed is a palindrome or not. So this is what we'll try to do. So let's see the approach for this code. We will simply iterate through the entire numbers and then means find the binary representation. I hope you will be able to find the binary representation. So what we'll do, we'll simply create a means empty string. Okay, initially it is empty. Now what we'll do, we'll check the last bit of a particular number. Suppose we have a number num, we'll see the last bit. If it is set, then we'll simply push 1 in this string, or we'll simply push 0 if it is not set. And after checking, we'll simply move the number ahead by 1 bit. That means we'll simply divide the number by 2. Okay, so you can do that. And then it will means the binary representation will be from LSB to MSB in the computer string. So we'll simply we can reverse this string and see whether both the strings are same or not. And if they are same, then that will be a palindromic means substring. So let's see the code for this approach. So we are simply we need to find the binary palindrome. So we'll initialize this count. Now we'll iterate for k from 0 till n, and we'll see for each k whether the means it is palindrome or not. Means we will be writing this function where we'll be finding its binary representation, and then we'll check whether that is the palindrome or not. So if it is a palindrome, then we'll simply increase our count. Now let's see the is palindrome function. So we have means if k is equals to 0, then since for k equals to 0 we were explicitly given that the number 0 is considered binary palindromic, so we'll simply return true only. Now create this empty string. What we'll do, while means k is greater than 0 means the MSB is still present, then what we'll do, we'll add in s if means k%2 is equals to 1, then we'll push 1, else we'll push 0. Okay, and then we'll move this all the bits one step to the right, that means divide the number by 2. Okay, now we'll find the reverse string of s and we'll reverse them and see like whether the reverse string as well as the original string is the same or not. And if they are the same, then that means this s that we have constructed is a binary palindrome, and hence in that case this count will be increased, and then we'll simply increase our count. Okay, so like as we can see, like will be of the order of n into, like we will be moving this k till the number of bits that means this k has. So the maximum number k can go up to is n, and the number of bits in n will be simply log 2 of n. Okay, so hence this will be like the overall approach for this problem. And let's see the constraints given. So we are given like n can go up to 1e15 here. So big of n only is not possible. And since 1e15, so 1e15 is like approximately what? 2 to the power 50, let's say suppose. So this will like means the n can have the MSB at 50th bit. So this will be of the order of like order of 50n. And since n can go up to 1e15, so it is of the order of 5 into 1e16, which is very huge and obviously will give us a TLE here. Okay, hence like based if the constraints were like till 1e6 or 1e7, then this approach would have worked. But here we need to like we need to get rid of this brute force approach, because obviously this is not going to get accepted here. So what can we do here? So we know like if n is up till 1e15, then obviously like either some solution of the complexity root n will work, or we'll need to like since it will have 50 bits, so maybe we need to only traverse through the bits, and then like just on the basis of the bits we try to calculate the number of binary palindromes, right? So moving through means the entire n was not possible. So from that we observed that instead of moving through the numbers, maybe we need to traverse through the bits, because that is what we need to do. We need to find their binary representation and then see. So what if like we try to iterate through the bits only and then try to make some observations. So let's try to do that. So what I'll do here is I will just go through the means the entire approach first, and like then we'll discuss the code, and then like that concept that we'll be using will become crystal clear. So like the problem that we have is, suppose we have a binary representation of a particular binary palindromic string. So that means the first k half that we have, suppose it was 1001. Okay, 1000, let's suppose. So for this entire binary representation to be a binary palindrome, that means the first half of the portion that we have, it should be mirrored in this. So this 0 should have 0 here, this 0 should have 0 here, this 0 should have 0 here, and this 1 should have 1 here. That means we'll be simply mirroring the first L, means len by 2 elements. Okay, and now what about odd case? So suppose it was 1 1 0. Okay, the first half was this, means n means length is total length is 5. So we'll keep this bit as same, and now we need to mirror them. So it will be 1 and then it will be 1 again. So this will be the binary palindrome for this. So what we are trying to observe here is, instead of like going through the entire length of the string, we can like just satisfy the condition for the first half of the binary representation and then try to mirror it and see like whether it will exceed n or not. And if it doesn't, then that is a good number. Okay, so this is what we'll try to do, and we'll try to see this because suppose n has like len equals to L. Okay, means the binary representation of n has, suppose it was this only 8. Okay, so then that means if n has 8 bits, means the MSB is at the 8th bit, then that means that if we want to find binary palindromes of length 1, then it will simply like we can account through all the possibilities, means no number will exceed like exceed this n. Okay, for len equals to 2 as well, we'll simply create this first portion and we can simply mirror without thinking, because it will obviously not be greater than n. And similarly till len equals to 7. Okay, because obviously this will also, we can simply pair the first 4 elements. Okay, and then we'll simply means mirror them here. Okay, so this will also definitely not exceed n, because we know like since this n has length equals to L equals to 8. So till 7 it will have the MSB till 2 ki power 6 only. Okay, and since it has the MSB at 2 ki power 7, and obviously 2 ki power 7 is greater than 2 ki power 6 plus 2 ki power 5 plus till 2 ki power 0. Okay, so if this bit is set, then even if we set all the bits here, it will still be less than n only. Okay, so that is what we're trying to see. Like for all n less than L till less than L, means for n equals to 0, we'll obviously have the answer as 1 only, because this 0 will be counting. Now for all n L less than L, we are free to choose the first half of the binary string. Okay, we are free to choose the elements. We just need to make sure that this first bit is 1, and we are freely choose, means we can freely choose all the length of the elements, means all the rest of the bits they can be 0 or 1, 0 or 1, 0 or 1. Okay, so we are free to choose these bits. That means the number of, means the length that we have, the number of numbers that will be possible here is, it will be suppose 1 1 1 1 1. So the maximum number that we will be able to get is 2 ki power the length that we are seeing for currently, 2 ki power length minus, suppose here length was 5, so it will be 2 ki power 4. So 2 ki power length minus 1. Okay, so for all possible, means all those binary strings which has a length less than L, in those cases our answer will be simply 2 ki power length minus 1, because we can freely, means we can make this bit as 1, and we can freely choose the remaining till length by 2 segments. Okay, and this length by 2 will be sealed to account the odd as well, to account this odd as well. Okay, for because 5 by 2 seal is 3. Okay, so hence in this case the maximum that we will get is 1 1 1, and we, even if we mirror it 1 1 1 1 1, it will still be less than the value represented here. Okay, so this is what we will do for all lengths from 0 till L minus 1. For all this it will be simply, if length is moving, so it will be simply 2 ki power length minus 1. Now what about the case of where we try to construct the strings which have the same length as our given n? That means for what about the case where length is equals to n? So in that case we need to make some observations, like if we have the prefix till, suppose k was L by 2. Okay, so we have the prefix till here. Okay, this is k, prefix of k. Okay, so if we we'll keep this the same as n, we are trying to find the upper bound that we can get. Okay, so we'll try to keep it the same as n. So suppose it was what, it was 1 0 0 0 here. Suppose it had been suppose 1 1 0 1. Okay, then we'll keep the same as 1 1 0 1. Now if we keep it the same and then try to mirror it, we'll may get value 1 0 1 1, and we see this value may become greater than that n we have. Okay, so we cannot, means if we simply make this prefix equals to k, we need to find this mirror part and then check for the value that we have constructed, whether it is less than or equals to n or not. Okay, but can we what about values which have whether prefix of k is less than prefix of n? Okay, means till this value, what about the values where suppose it was 1 1 0 0? Okay, so in this case it will be since we have unset this bit, so even if we mirror it, we'll know since setting this bit will definitely be greater than setting all the bits on the right. Okay, so hence what we'll do here is, if for finding out the prefix of k less than or equals to prefix of n, we know that then we'll have the liberty of choosing all possibilities from what, here it will be 1 0 0 0. The first possibility that we have is this, and the final possibility will be, instead of 1 1 0 1, we'll go till 1 1 0 0. So all the numbers between this range will be our answer for all the prefixes which are less than prefix of n. And for prefix of a equals to prefix of n, what we'll do, we'll simply mirror it and see whether that particular value is less than or equals to n or not. And hence this will be for length equals to L, the scenario will be for length equals to L, the scenario will be, the first case will be for prefix k less than prefix n. So that means the case will be here, the left bound that we have, this is L and this is R. So we need to account all the numbers between L to R. So this L will be what? Simply it will be the K that we have. That means 2 to the power K, which was L by 2. So 2 to the power K minus 1, because it is simply 1 0 0 0. So K is the length, then it will be 2 to the power K minus 1. Okay, K minus 1 is the power. Now what you will see, so it will be the result, and the R here will be what? It will be the value represented by this. So it will be what? Prefix of K. Prefix of K means it is the value which is same minus 1. Okay, so R here will be this. So hence the total number of lying numbers which lie in the range will be R minus L plus 1, which is simply prefix of K minus 1 minus L plus 1. So this minus 1 will be cancelled by plus 1. So it will become simply prefix of K minus 2 to the power K minus 1. Okay, and this prefix of K is nothing but prefix of N, because we are using the prefix of K is equals to N here, so that it remains the same, and then we are reducing it by 1, so that if we means will be, when we are reducing it, it will definitely unset some bit, and we unset that bit, then all the numbers on the right, even if we set them or take mirror, it will not affect, like it will not become greater than N. Okay, so this is like the entire formula, and for prefix of K, for the same only, for prefix of K equals to prefix of N, we'll construct this palindrome manually, construct this string manually, and see whether it is less than or equals to N. So this is like the overall approach for this problem. Let's try to see it once again. So what I try to do here is, instead of like going through all the numbers, since N can go up to 115, we try to go through the case only. Okay, we try to go through the bits only. Now since we need to make binary palindromes, so we saw like if we just simply construct the first half of the palindrome, then if we simply mirror it, the other half will be automatically constructed. Okay, so but just on the basis of what if we would simply try to create the first half, and then on the basis of that first half we try to see all those numbers which are less than or equals to N. Now for creating those first halves, we try to see like the number of bits that will be present in the binary representation of N. In that case, all those lengths of bits which are less than that particular N, because here the length was 8. So all those binary representations which has a length less than the binary representation of N, all those we can arrange in any possible manner, because obviously even all means it will never exceed N. Okay, because the MSB that is set in N will never be set in all those bits which are less than L. Okay, so for length less than L, what we try to see the formula was, it was simply for all lengths it will be 2 to the power len minus 1. So for 0 it will be simply 0, means for it will be simply, so we can initialize the answer as 1, and for all length from 1 till L minus 1 it will be simply 2 to the power L minus 1. Okay, now what about the case where length was the same as the given string? So in that case we try to find out, right, we try to create the first prefix. So we try to create the first prefix, we try to find out a range of elements that can be possible, such that this prefix is still, after mirroring, it still remains less than N only. Okay, so in that case we try to find out the L bound as well as the R bound. Now the L bound will simply set the first bit and unset all those bits, and then we'll simply mirror it. So if it is or not already equals to N, then we'll be simply getting the answer as L equals to this one, 2 to the power K minus 1. And R that we'll having, it will be simply, since we will making it the same as prefix of N only, maybe after reversing the values will become greater than N. Okay, so instead what we try to do is, we try to see till prefix of N minus 1, prefix of K or prefix of N minus 1. Now that will make sure that even after mirroring, since we are reducing from this portion only, which is lying towards the MSB part, then even if we reduced this, then we'll be unsetting some bit from this portion. Hence obviously if we mirror the remaining part, then it will never exceed N. So that was the core logic of finding this R. Now the numbers in this range will be R minus L plus 1, which will be simply prefix of N minus 2 to the power K minus 1. And what about the case where we will keep the same prefix as the prefix of N? So we'll simply we need to greedily construct the entire string after mirroring, and then we'll see whether the constructed number is less than or equals to N or not. And if it is, then we simply increase our count by 1. So this was the overall approach. Let's try to see like a walkthrough of the examples. this was the entire explanation that I prepared, but I got through normally only. So for count palindromes, length less than L will be simply length minus 1. Okay, for all length from length equals to 1 till L minus 1. And for length equals to 0 means since length equals to 0 is simply not defined. So for accounting 0 will update initialize our answer with 1 only. And now what about the cases where count palindromes with length equals to L? So we'll extract the first L by 2 bits. Let this prefix value be P of L. So the smallest prefix possible will be 100, which is simply 2 to the power m minus 1, and any prefix which lies between from 2 to the power m minus 1 to this p val minus 1, we generate a palindrome which is strictly smaller than, because the most significant bit dominates the value. Hence the count of such prefixes will be simply this p val minus 2 to the power m minus 1. Okay, and finally we'll check whether the palindrome generated by this p-val itself is like the means palindrome or not. Okay, so we'll construct the palindrome using this p-val, which remains the same as p means which will remain the same as n for the first m bits, and will, if this constructed value is less than or equal to n, we'll simply increment our count by 1. So let's try to see a particular example with means using this approach and see how this will be working. So for suppose we have binary string of length, means binary string 9 of length equals to 4. So for all length from L equals to 1 till 3, we'll be using the formula what? To give our length minus 1. So initialize answer equals to 1 for counting the number 0. Now for shorter lengths, we have L equals to len equals to 1. So the first part will be len by 2, which is m equals to 1 by 2. Okay. So it will be what? It will be 2 to the power m minus 1. Means here it was this length that we have, means it will be suppose L dash, L dash will be what? Seal of length by 2, as you know, because we are only seeing the first means length by 2 L by 2 bits. Okay, I hope like I did not confuse you here. So this is what we do. We'll check for ln equals to 2, the first m by 2 bits will be 1 only, and then for ln equals to 3 will the first m by 2 bits will be 2 bits. Okay, so here the case will be 2 to the power 2 minus 1 means 1 0. Okay, so the number 2 here. So these two numbers are 5 and 7. Here for len equals to 2, the number was count was 1 and the number was 3. And for len equals to 1, the count was 1 and the number was 1 itself. Okay, so overall we have got 5 counts here for length less than 4. Now what about length equals to 4? So length equals to 4, let's try to find the range from what? 2 to the power means p val minus 2 to the power k minus 1. So let's try to find this. So prefix of first n bits is 1 0, which this means p val is equals to 2. Okay, and now smallest base will be 1 0 only, which is also 2. Since this value will be simply 0, so there exists no means binary palindromes which will be like less than 4, because means n is given in such manner that 1 0 0 1 0 0 1. So if we simply decrease minus 1 here, it will become 0 0. Okay, that's why we have got 0 count. Now what about the case where we are checking for keeping the 1 0 part same only, and then try to means mirroring this. So we try keep this same part and then create the mirror part, then we'll see like this value is 9, and which is less than or equals to 9 itself. Hence we'll be increasing our output by 1, and so far we have got answer as 5. So in the final output it will be 6. So I hope like you are able to grasp how just on the basis of first k bits or first length by 2 bits, we are judging like means we are accounting through all possibilities of assigning bits, such that the remaining number can be simply mirrored according to the number on the MSB, because obviously we can mirror the part on the MSB because that will obviously have a greater weightage than all the bits on the left side. Okay, so that is what means that is what was useful here, and then we try to simply see the approach. So let's try to see the code as well for this algorithm, and then like it will be more clear, because it is like pretty hard to like just visualize all of these things. So let's try to see the code, and then then I think the things will become more crystal clear. So what we'll do here, if we have the n as 0, we'll simply return 1. Now what do we need to find? We need to find the number of bit, means the length equals to L. We need to find the number of bits means the length of the binary representation of this n. So here we are finding the binary representation of n. So we create this temporary string and we do the same that what we did in the brute force approach. We are doing the same only here. Okay. So create this means binary string of, now we'll be able to find this L using s dot size. So this L will be allowing us to move from 1 till L minus 1, calculate the result, and for L we'll be calculating the result separately. Now, so for length equals to 1, and this is for number 0, we have account as initially 1 only, since we have accounted that. Now for length equals to 1 till n minus 1, we'll be moving the length. Now the half length will be CL of means length by 2, and I hope like you know, if you want to do a CL division of a by b, it is simply a plus b minus 1 by b. Okay, so it will be simply what, length plus 2 minus 1 by 2, which is length plus 1 by 2. So that is what we are doing here. We are finding out the half length and then simply updating our count with 2 की power means half length minus 1. Okay. Now once we have do that, we need to account the case where we will be finding out for the length L only. Okay. So first we will see for all prefixes which are like prefix k which is less than prefix of n. So it will be what? It will be prefix k minus 2 की power k minus 1. Okay, so the half length that we have here is L plus 1 by 2. So we'll find out this prefix value that we have. Now, how will we be finding this prefix value? So we already have the binary representation of n, okay, in S. And it is from like the binary representation that we have constructed here. It is pushed in such a manner that first we have the LSB, then moving till the MSB. S is in this form. Okay, so if we want to construct the means the first k bits from the MSB, we'll be needing to traverse to this S from the end. Or we can simply reverse it as well. So both are fine here. So that's why we are like moving for all half lengths, and then what we'll do here is means moving in the half length of the index. So the bit index will be simply what, n minus I plus 1, n minus I minus 1. Okay, because I equals to 0, so its pair will be stored at n minus 1. Or I equals to 1, it will be n minus 2. Okay, so this is like, since we need to traverse from the end, that is what we have done here, and the prefix value will be simply, if like this bit is set here, then we'll need to means we'll need to set the prefix value at that particular bit. Okay, so at that particular bit we'll be setting it. So hence we'll be setting that particular bit, and it will be in the form of 0 1, means it will not be in the form of 0 1 2. It will be like, since we had like 0 1 2, so it will be n minus 1, n minus 2, and so on. Hence we need to convert it into 0 1 2, so that we do this to convert this half length to of this form. Now once we have this ready, what we need to do here is we need to find out the base, means which will be what, prefix of k minus 2 की power k minus 1. So the base will be simply one left shift to means half length, which is 2 की power half length minus 1. Now the number of ranges in the range will be the difference of these two values. So it will be prefix val minus base. And for now we need to account the case where we'll be keeping the first half length part same and then mirroring it. Okay, so it will be same as prefix of n only, and then we'll be mirroring it to see whether the new constructed value is less than or equals to n or not. This was the case for the final case. Okay, so we need to construct this palindrome from the prefix value that we have till length L. So we'll call this construct palindrome function, and if the number that we have formed is still less than or equals to n, then we need to increase our count by 1. Now how do we like construct this palindrome? So let's see the construct palindrome function. So we have the result as initially as prefix. Okay, initially we have the result as prefix only, and now we have length by 2 bits to mirror. Okay, we have means we are already given the entire length, and these many bits we have to mirror. And now if it is odd, means it is simply what, length plus 1 by 2. Okay, so if this is of odd length, then if the odd is means length is odd, then we need to, what do we need to do? We need to move the prefix value that we have already created to one step to the right. Okay, so that we are only accounting the first k bits, mirroring the first k bits, and this bit still remains the same only. Okay, so we'll be simply make this prefix k that we have till means we'll move it one step right, so that we only have these bits values, and this will still remain the same only. Now what we'll do, we'll need to append these bits to the means initial prefix that we had. Okay, or we can simply push it into result. Okay, so we'll be pushing this in the reverse fashion in this result integer that we have calculated. So what we'll do, we'll iterate through the bits that we need to mirror. Now for this, we'll need to like see from the end on. Okay, so we need to see, we'll see like result means the result that we have initially. What we'll do, if it is 1011 initially, since we need to mirror this one here, so what we'll do, we'll see whether means this was a prefix, so we'll move it one step previous. Okay, so it will become 1011 and it will be dash. Now what you need to see whether with what bit we need to set this value. Okay, so we need to set this bit with this value. So we'll see whether this bit is set in prefix or not. So since this bit was set in the prefix, hence we'll be replicating it here. So we're taking OR with, if the prefix in prefix this bit is set, then we'll be putting 1 here. Now in the next case, we need to move the prefix one step righter so that the new prefix is 101 and the result that we have currently is 10111. Okay. Now again we'll move result by one step left. So this will become this. Now we see whether it is set or not. It is again set. So we'll be replicating this bit here. So it will be 1. Okay. Then simply the new prefix will become 10. Then we'll see it will become 10. Result currently is 10111. And we need to replicate this 0 here. So we see like this is not set, so we'll be doing 0 here. Now the prefix will become 1 only, and the result that we have generated so far is 1011110. And we move result one step previous, and it is set, so we'll be setting it. And this will be the final result that we will be getting, and it will be simply the result of mirroring this part, means 1011 and then 1011. It remains the same. Now we'll simply check whether this formed string means we will be returning this result, and in the end we are checking whether the string that we have formed is less than or equals to n or not. And if it is, then we'll simply increase our count. So this was the overall approach for this problem. I hope like you are able to follow, because it is like pretty lengthy as well as pretty hard. So you need to like try and make observations on your own. And let's discuss the time complexity as well. So we see that maximum n can go up to 2 to the power 50. So this L that we have here will be till 50 on. Okay. So we are going through all the L's, which will be order of 50. And here also we are going till half n, which will be order of 50 on. Hence the time complexity is like of the order of like constant complexity only. So this will be like the most optimal approach for this problem. I hope you are able to follow along with the approaches. Let's try to submit this code, and like since it is of the order of complex means constant complexity only, so it should like run very fast. So let's see how much time it takes. Okay, we have removed something. It will be int. Let's run it first and see where it runs or not. And it runs. Let's try to submit it, and like it should run very fast, I think, because as you can see, like it runs in 3 ms, which is very fast because of the order of constant complexity only. So based on a LeetCode server, this is decided. Maybe if it will be submitted different times, it will give, maybe it will run faster or run smaller. So this does not matter, because we know that the complexity that we have written the solution for is very less. So I hope like you were able to follow along with all the approaches, and if you did, make sure to like as well as subscribe, because this was a pretty tough problem to explain as well, and discussing the entire flow of the algorithm. So if you did, make sure to like as well as subscribe, and if you yet have any doubts remaining, feel free to comment down and I will be happy to help. Thank you so much for watching.